Today we are solving LeetCode 19779, find greatest common divisor of array. This is an easy problem, but it teaches some very important DSA concepts. What is GCD? How do we find the minimum and maximum in an array? Why do we only need the smallest and largest elements? And most importantly, how does the Euclidean algorithm work? So do not skip this problem just because it looks easy. Small problems are where we build strong fundamentals. We are given an integer array nums. We have to return the greatest common divisor of the smallest number. We have to return the greatest common divisor of the smallest number and the largest number in the array. Let us understand this line carefully. We are not finding the GCD of the whole array. We are only finding the GCD of two numbers. The smallest number in nums and the largest number in nums. For example, nums equal to 2, 5, 6, 9, 10. So the smallest number is 2, GCD of 2, largest number is 10. So we need to find GCD of 2, 10. Now the common divisors of 2 are 2 and 10 and 1, 2. So answer is equal to 2. GCD stands for greatest common divisor. It means the largest positive integer that divides both numbers completely. For example, GCD 12, 18. Let's compute this. So divisors of 12 are, there is 1, 2, 3, 4, 6, 12. And divisors of 18 are 1, 2, 3, 6, 9, 18. So greatest divisor is greatest common divisor is 3. So 3, not 3 but 6. The 6 is here and here also. So 6 is the greatest common divisor. So our GCD 12, 18 is equal to 6. Now let us think about the problem. We are given an array. The problem says find the smallest number, find the largest number, return their GCD. So this problem can be broken into two smaller tasks. First is scan the array and find minimum and the maximum. And second, calculate the GCD of those two numbers. So this is a very common DSA pattern. When a problem looks big, break it into smaller independent steps. So we have array problem plus math problem. The array part is finding minimum and maximum. The math part is finding GCD. The simplest approach is use min nums to find the smallest number and use max nums to find the largest number. Then find the GCD. In Python, we can directly use the built-in GCD function, but for learning DSA, we should understand how to write GCD ourselves. So first, let us understand the basic GCD method. Suppose we need GCD a, b. One simple idea is start checking from min a, b down to 1. The first number that divides both a and b is the GCD. Example, a equal to 8 and b equal to 12. So min of a, b equals 8. Now we start from 8, 7, 6 till 1. Now the first number that divides 8 is the GCD. That divides both 8 and 12 is the GCD. So 8 divides 8, yes, but 8 does not divide 12. So this is not the GCD. 7 divides 8, no. 7 divides 8, no, so it is not the GCD. 6 divides 8, again no, not the GCD. 5 divides 8, no. 4 divides 8 and 4 divides 12 also. So GCD is 4. Answer is 4. This works, but it can be slow if numbers are large. The time complexity of this GCD method is order of min a comma b. So it has linear time complexity. For this problem, constraints are small, so it would pass. But in DSA, we should learn the better method. The optimized way to find GCD is the Euclidean algorithm. So let's discuss Euclidean algorithm. The idea is this: GCD a comma b equals GCD b comma a mod b. We keep doing this until b becomes 0. When b becomes 0, the answer is a. Let us take an example: GCD 10 comma 2. So we apply the Euclidean algorithm: a equal to 10, b equal to 2, a mod b equal to 10 mod 2 equal to 0. So GCD 10 comma 2 equals GCD 2 comma 0. So the answer when the second number becomes 0, answer is the first number. So answer equals 2. Let's take another example: GCD 8 comma 3. So 8 mod 3 equal to 2. So GCD 8 comma 3 equals GCD 3 comma 2. Now 3 mod 2 equals 1. So GCD 3 mod 2 equals 1. So GCD 3 comma 2 equal to GCD 2 comma 1. And 2 mod 1 equal to 0. So GCD 2 comma 1 equal to GCD 1 comma 0. Now second number is 0, so answer is equal to 1. So GCD 8 comma 3 equals 1. Now time complexity. It will be order of log of min a comma b. So earlier our time taken was linear, but this time it is logarithmic. Let us understand the intuition simply. Suppose we have two numbers a and b. Any number that divides both a and b will also divide the remainder when a is divided by b. For example, a equal to 18, b equal to 12. So this is intuition behind Euclidean algorithm. So let's take this example. When we divide 18 by 12, that is remainder is 6. So GCD 18 comma 12 equals GCD 12 comma 6. Why? Because any common divisor of 18 and 12 must also divide the difference or remainder. Then 12 equal to 6 into 2 plus 0. So answer is 6. This is the core idea behind Euclidean algorithm. Now let us write the algorithm for this problem. So step 1 is algorithm for this complete problem. Step 1. Find the smallest number in nums. Step 2. Find the largest number in nums. Step 3. Apply Euclidean algorithm on the smallest and largest. And step 4 is return the GCD. Now let's write the pseudocode for this problem. So we'll get the smallest and largest while smallest is not 0 because we stop when the smallest becomes 0. Reminder equals largest mod smallest. Largest equals smallest and smallest equals reminder. And finally when it becomes 0, we return the largest. But to make the GCD function clean, we can write it separately like this. Function GCD a comma b while b is not 0, temp equal to a mod b, a equal to b equal to temp, and return a. And then write function find GCD like this. Okay, so now let us write the code. We get smallest equal to min nums and largest equals max nums. Then finally return the GCD, where we define GCD like this. While b not equal to 0, we update the values of a comma b and return a when the loop ends. So this is it. First we find the smallest number, then we find the largest number. Now we call our helper function. Inside the GCD function, we continue until the second number becomes 0. And this line in Python, this line means the new number becomes b, the new first number becomes b, the new second number becomes the remainder of a and b, a mod b. Finally, when b becomes 0, we return a. Now let's try run this example. Let's take this example. Num is equal to 7, 5, 6, 8, 3. So smallest number is and largest is 8. Smallest is 3 and largest is 8. Now GCD 3, 8. This function will execute. Initially a equal to 3 and b equal to 8. Then in the loop 1, so a becomes 8 and b becomes 3 mod 8 equals 3. Then in the second iteration, a equals 3 and b equals 8 mod 2 8 mod 3 equal to 8 equal to. Now in the next iteration, a equal to 2, b equal to 3 mod 2 equal to 1. And in final iteration, a equals 1 and b equals 2 mod 1 equal to 0. So now we return, because b is 0, we return 1. So the answer is 1. Let us check with nums equal to 3, 3. Smallest number is 3 and largest number is also 3. Now GCD 3, 3. Now since both the numbers are same, their GCD is the same number. So this case also works. Now let's compute the time and space complexity. So finding the minimum takes order of n. Finding min takes order n time. Finding max takes order of n. GCD calculation takes order of log of GCD calculation log of min of m comma n. So total time complexity is total order of n plus log min m comma n. It will not be m comma n but the min value of the array. So usually since scanning the array dominates, we can say the time complexity is order of n. So it will be ON, linear time complexity. And space complexity is constant, no extra array is required. Can we optimize further? Currently we are doing min-nums and maximums. This scans the array twice. We can also find both minimum and maximum in one loop. That would still be ON, but slightly better in practice. So we can modify the code. So smallest and largest are initialized by nums 0. Then we go through the array and check if check both largest and smallest in the same scan. So for LeetCode, both versions are perfectly fine. For beginners, the first version is simpler and cleaner. So we can submit by the second version. Let's see if the test case passes or not. Let me comment out everything except the code. Okay, test case is passed. Now let's submit the code. Okay, so it has been accepted and beats 100%. So that's great. So what we have learned from this problem, we learned four important things. First, how to scan an array and find the smallest and largest elements. Second, what GCD means. Third, how the brute force method for GCD works. Fourth, how the Euclidean algorithm optimizes GCD calculation using modulo. This is a small problem, but the same GCD concept appears in many bigger problems involving numbers, factors, divisibility, fractions, and modular arithmetic. Now let's look at the common mistakes that are generally made while solving this problem. So one common mistake is finding the GCD of the entire array. The problem does not ask for that, it only asks for GCD of smallest and largest number. Another mistake is confusing divisor and multiple. GCD means the largest number that divides both numbers. Another mistake is using a slow brute force method in problems where numbers are very large. For this problem it may pass, but Euclidean algorithm is the better habit. Another mistake is writing the loop condition incorrectly in GCD. The safest version is this, the one that we have used while b not equal to 0, a comma b equals b comma a mod b. So this was LeetCode 1979, find greatest common divisor of array. The main learning from this problem is not just solving the question. The main learning is understanding the complete idea, the complete process of solving the question. In the next problems, whenever you see divisibility, factors, or common multiples, remember this idea. Use GCD, and for GCD, use the Euclidean algorithm.